Hello everyone. Today we will discuss about the sample question paper of class 12 2024 to 25. This is new for the session and the subject is mathematics and code is 04. So these all are the instructions which are given in the question paper and this is a section number A. Each and every question of section A is a 1 marks question because of all these are MCQ based questions. Question first talk about the square matrix of A. This is given. Then the value of determinants A plus adjoint A of the determinant is equal to. So let us understand with the help of the solution which one is the correct option for these questions. So the given part is A. Adjoint A is equal to 2025 0 and 0 0. This is given in the questions. So with taking common 2025, so it will become 100 010 001. This is a identity matrix, so we can write like that. So after that we know that is equal to determinants of A and identity matrix. So if we compare this one from previous one, this, so left hand side are equal, so the determinants of A, the value of this determinant will be the 2025. So this is the value of this one, and after that, if now we have to find this one, we have this value, and we after that we have to calculate determinants of adjoint A. So for this, we know adjoint A is equal to determinants of A raised to the power n minus 1. So this matrix basically 3 cross 3 matrix. So where n is order, this n is order of matrix, given matrix. So now let us understand how can we solve this next part. So for this, n is 3 cross 3, so n is equal to 3. So it will become, and the value of this is we all know. So the question talk about, and this is the value of adjoint A, determinant. Now find determinant of A plus determinant of adjoint A is equal to 2025 plus 2025 square. Basically, this is the value of this. So option D is correct option. So that is a solution of the question number 1. And after that, the question number 2, assume x, y, z, and w and p are matrices of the order this, and this, and cross k. So respectively, then the restriction on n, k, and p, so that py plus wy will be defined as. So this is a basically question number 2. For this, we all know question number 2. The order of, assume that P, X, Y, Z, W, and P are matrices of order this. So these are the order of the matrix X. This is the order of matrix X. This is the order of matrix Y and Z, W, and P. All order are given. So order of, if we find, first of all find order of P. So the order of P is order of P. So P in the last, so last order will be P comma K. Order of P is P cross K. Same as it is order of X is given. Order of, if we want to write the order of Y, so Y is Y here is in second position, so order will be 3 cross K. So this is the order of Y. And after that we have to find Py. So if we multiply both matrix Py, so order should be multiply. So order of P is P cross K and order is Y is order Y is P cross K. So according to this, this and this should be equal. So K, the value of K will be 3. We can go through that if the value of K in this is not correct because K is arbitrary and here the value of K is 2. So this is also incorrect. So option number, possibility of option number A and C. Let us find out the another one, WY. So for this the order of WY. So W, order of W is open is 1, 2, 3, 3 cross 3 and cross 3 and order of Y 3 cross K. So this both are equal. So 3 is equal to 3 since we have already discussed K is equal to, here K is equal to 3. So from here N cross K will be the order and from here P cross K will be the order. From PY P cross K will be the order and from WY N cross K will be the N cross K will be the order. So P and K will be cancelled. So P is equal to N. And P is equal to N in the option number first. This order and this order should be equal. The rest of the order is P and K. So from here and the order of this and this should be equal. So order of N and order of K should be equal. Okay, so according to this we can simplify and find which one is correct. B option is correct and C is also wrong. And after that question number 3, the interval in which the function f defined f is equal to e raised to the power x is strictly decreasing in, there are 4 options given here. So for this we have to, the function equation is given y is equal to e raised to the power x. So we have to find dy by dx, differentiate this equation. So with respect to x, so it will become e raised to the power e. So this is basically differentiation. So now question number 3 talk about this strictly increasing. So for increasing in the domain R of the function dy by dx is greater than equal to 0. Hence the function is strictly increasing in because this is positive. So we can write dy by dx is greater than is equal to is greater than 0. Dy by dx is greater than 0. So we can write hence the function is strictly increasing. Hence the function is strictly increasing. Increasing this shows that the increasing function between which value, because of this is a positive function, so we have to write like that minus infinity to plus infinity. So this will be the correct one. So option number C of this question should be the correct one. Now let us move forward. Question number 4. Question number 4 talk about if A and B are non-singular matrices of sum of the order determinants A is equal to 5, then determinants B inverse AB square is equal to. So this is a question number 4. This is a question number 4. So determinants is given. So we can write like that determinant A is equal to 5. Now we have to find the value of this one. For this one and this one will be eliminated. So we can write like that, so that this will be the 5 square. So your answer will be the B part. It's easy, so you can easily solve this. And now after that, we should talk about the question number 5. Here, question number 5. So the value of n such that the differential equation this is given where xy belongs to positive real number in a homogeneous is. So for which value this function will be the homogeneous, we have to find this. So question number 5. We all know for the homogeneous function, first of all find the differentiation of this equation. So equation is x and dy by dx is equal to y log y log x plus 1. So dy by dx is equal to y over x raised to the power n log y minus log x plus 1. So basically we should let this one fx comma y is equal to y over x raised to the power 1 log y minus log x plus 1. This is a number 1. And after that we should replace, we have to find lambda x, lambda y. So we have to replace x with lambda y and y with lambda y, x with lambda x and y with lambda y. If this and this both are equal, so we have to prove function or equation which are a differential equation will be the homogeneous. So now the next part will be of this question. We have to find f lambda x and lambda y. So the equation will be lambda y over lambda x raised to the power n log y minus log x plus 1. So we can write like that lambda over lambda raised to the power n y over x raised to the power n log y minus log x plus 1 lambda x lambda y. If we compare relation equation number 1 and equation number 2, so we can find it out both equations are the same, but a simple difference is this part is only extra in this equation. So if we eliminate this part, so how can we eliminate this? If n is equal to 1, we have to put n is equal to 1 in this equation, so both equation 1 and 2 should be equal and function will be the homogeneous. The condition is also for the homogeneous if equal to lambda x and lambda y, so we can say function is homogeneous. If we put n is equal to 1 in here, so y and lambda should be cancelled out and equation 1 and 2 will be equal. So for n is equal to 1, equation will be the homogeneous. So here option number B is correct. Now let us discuss question number 5, 6 question number. We have already discussed question number 1 to 5, and now we have to discuss question number 6. If the point this and this are collinear, then x1 y2 is equal to. So for this we will know the condition of collinear. Question number 6, x1, x2, x3, y1, y2, y3 is equal to 0. So for this x1, x2, y1, y2, 1, this is also 1, and this is given x1 plus x2, this is y1 plus y2 and 1 is equal to 0. Solve from here, so 1, it should be this multiply with this, so it will become x2 y1 plus x2 y2 minus, after that this multiply with this, minus x1 y2 minus x2 y2. After that minus 1, this will take, then solve it, x1 y1 plus x1 y2 minus x1 y1 minus y1 x2. After that this you can multiply directly, x1 y2 minus y1 x is equal to 0, and open all the bracket, so you can find x2 y1 plus x2 y2 minus x1 y2 minus x2 y2, after that minus x1 y1 minus x1 y2 and plus x1 y1 plus y1 x2 plus x1 y2 minus y1 x2 is cancel with this, and this x2 y2 cancel with x2 y2, and after that x1 y1 cancel with x1 y1, x1 y2 cancel with x1 y2, and rest of the part is minus x1 y2 plus y1 x2 is equal to 0. So this we can write like that, x1 y2 is equal to y1 x2. So in the question x1 y2 is equal to y1 x2, or we can also write like that x2 y1. So option number A is correct. Now let us move forward. Option number 7. Matrix is a skew symmetric matrix, then the value of A plus B plus C. So A is given, matrix A is given 0, minus 1, 2, 1, A, 3, C, minus B, 0. We all know for the skew symmetric matrix, or skew symmetric, A transpose is equal to negative A. So we can first of all find out A transpose, and after that negative minus A. So A negative of this one minus A is equal to, it will become 0, minus 1 minus C, 1 minus A, B, minus 2 minus 3, and 0. This is a minus a negative matrix of A, and A transpose, we have to change the row into column into row. So A transpose is equal to 0, 1, C, minus 1, A minus B, 2, 3, and 0. And minus A should be this one. So we can also write like here 0, 1, minus 2, minus 1, minus A, minus 3, minus C, B, 0, and compare all these. So we will find the value. C is equal to minus 2 and B is equal to 3, and for A is equal to minus A, so we have to done with this 0. So 2A is equal to 0, so A is equal to 0. Now the question talk about A plus B plus C. A is 0, B is 3, and minus 2. Value is 1. So option number A is correct. Now question number 8. Question 8. For any two event A and B, if probability of event not A is equal to 1 by 2, probability of event not B is equal to 2 by 3. So this is given So we have to find from here probability of A is equal to 1 minus 1 over 2. So it will become also 1 over, and same as it is probability of given, this is given 2 by 3. So probability of B is equal to 1 minus 2 by 3. So it will become 1 by 3. And A intersection B is equal to 1 by 4. And find this one. So for this, we all know the formula of this. For PB bar. So this formula basically become PA union B whole bar over PB, and after that this will become 1 minus B A union B over. So basically we have to find this one. So with the help of the formula, this is equation number 1. So P A union B, we all know PA plus PB intersection PA intersection B. So all values are given. PA is 1 by 2, PB is 1 by 3, and PA intersection B is 1 by 4. When we solve this one, we will get LCM 12, 6 plus 4 minus 3. So it will become 7 by 12. So P A union B is equal to this. Now we have to find this one. P is equal to 1 minus 7 over 12. PB is 2 by 3. Solve this one. So 12 minus 7, 5 by 12, 2 by 3. This will go with this and this with this. It will become 5 multiplied 3 over 2 multiplied 3. So this is 5 over 8. Option C. So option number C will be correct for this solution. Now let us move forward. Question number 9. Question number 9 talk about the value of alpha if the angle between this vector and this vector is obtuse. So we all know the angle between two vector cos theta is equal to, suppose this is a vector P dot vector Q over magnitude of the vector P and magnitude of vector Q. This is basically the formula between two vector angle. We have to find angle between two vectors. So here given is angle between alpha. Alpha is, so in place of angle we can take alpha and now alpha is obtuse. So cos alpha will be, so for obtuse angle cos alpha should be less than 0 because of that angle is obtuse. So if cos alpha less than 0, so we can write like that: vector p dot vector q, magnitude of vector p, magnitude of vector q less than 0. So we have to find first of all less than 0. So p is given 2 alpha square iota unit vector minus 3 alpha unit vector plus k unit vector dot I unit vector plus j unit vector plus alpha k unit vector less than 0. So we have to solve this one. So 2 alpha square minus 3 alpha plus alpha less than 0. So it will become 2 alpha square minus 2 alpha less than 0. So 2 alpha and alpha minus 1 less than 0. We can write this like that: alpha minus 1 less than 0. So we have to check plus infinity minus infinity, in which interval the value should be negative. So suppose this is relation 1. We have to any random value from this interval 0 to minus infinity, suppose minus 1. So minus 1, we have to check minus 1 minus 1. So here will become 2 less than 0. So this is a basically positive. So between this will become positive. And now let us check between the interval 0 to 1. So we have to put any random value, suppose 0.5 in same equation. So 0.5, 0.5 minus 1 less than 0, 0.5 minus 0.5 less than 0. So this will negative, this will become minus 0.25 less than 0. So this is negative. So value exists between this interval. Value exists in this interval. So alpha should be, so alpha belongs to